Almost 2 years ago, I blew up the electronics of my mini lathe. A loud bang, and I was sitting in the dark. After re-establishing power in the basement, I found out that the lathe was actually still running, but only at full speed. Somehow the speed control electronics died all of a sudden. There are actually replacement parts for this machine, but given the price and the chances of failing again, I decided to go another way. Instead of using the original motor and control electronics, I ordered this kit from eBay. It's a brushless servo motor intended to be used on industrial sewing machines, but it's also well suited to power small machine tools like a mini lathe. The kit comes with the motor and a small box which contains the control electronics. To be honest, the controls are a bit strange for the use on machine tools, as the motor is operated by this spring-loaded foot pedal switch. But I found a very elegant way to implement it into the machine controls, as you can see in one of my older videos. Also, I made a detailed video on the motor upgrade, so I will keep that short here. Size-wise, both motors are pretty much comparable. The new brushless one is even a bit shorter and at the same time way more powerful than the old brushed one. Thanks to its size, the new motor fits extremely well into the place of the old one. I'm running the lathe now for about 1.5 years with the new motor, and I'm still very pleased with this upgrade. The only thing which bothered me since then was the box with the control electronics. It was just flying around behind the machine and very impractical to reach and use. To solve this problem, I designed a proper electrical cabinet for the control electronics, which will be installed behind the machine's headstock. As I can't do proper sheet metal work in my small workshop, a friendly colleague made and sent me this thing of beauty. Instead of the original simple on-off switch from the controller, I wanted a double push button to start the machine. So I contacted Eaton, and they thankfully sent me this beautiful double push button from their product line. This type of button is widely used on industrial grade machine tools, and it will give a nice professional look to my machine as well. For the rest of the electronics, I got help from the German company Klinger & Born. They make all sorts of electrical components and thankfully provided me with an emergency switch, a nice main switch and a contactor. The contactor is needed to work with the double push button, so that the machine will stay under power when the on button is pressed and gets switched off when the off button is pressed. They also sent me this little fuse holder, which can be mounted beside the contactor. And this will be the master on-off switch. Above the main switch, I left a cutout for an operating hour meter. Not that this is really necessary, but it looks cool and it might be interesting to monitor the working time. Before painting the cabinet and installing everything, I had to drill a few extra holes, as the position of some components have changed in the meantime since my plans from over 1.5 years ago. I also had to fill the holes in the corners before painting with some sort of metal putty. Last thing before painting is to mount the little cap rail, which will hold the contactor later. And that's the electrical cabinet after spray painting. Well, it's not perfectly flawless, but as I really don't like doing paint jobs, I'm pretty pleased how it turned out. The first step now is to install this aluminum plate I made to conduct the heat away from the controller's main circuit board to the metal housing. For optimal thermal transmission, I put some heatsink compound between the surfaces. The next thing to install are these plastic spacers I made, which will hold the main circuit board later. I also had to make two mounting bolts for the small display board. Unfortunately, I forgot to cut the threads before painting, so I'm already chipping away some of the fresh paint, which is pretty annoying, but there will be a plastic cover installed later, which will hide the flaws. And that's the plastic cover I made for the control panel. Now it's time to disassemble the original controller to extract the two circuit boards. I obviously made some miscalculations in my design and now found out that the holes in the cabinet don't line up with the buttons on the board. So I had to widen and reposition the 4 button holes, which at this stage isn't the easiest task to do on my small milling machine. So the result looks really horrible, but it works, and in the end you won't see it anymore. I also had to make this steel cover plate with the right sized holes for the cable fittings. Beside the main power and motor cable, this little connector for the speed control sensor will be mounted here and is the first thing we start with. I had to cut the old cable to solder it to the new connectors. With the cover plate in place, I can now install the fitting for the main power cable and finally start all the wiring. And that's the cable I chose for main power input. First thing is to prepare the ground wire, which will be screwed onto the main circuit board later. And now it's time to connect the input line to the main power switch. With this done, I had to rip apart a short piece of cable to get some connecting cords for the next wiring steps. For a safe connection, I'm using some cable end sleeves here. And now it's time to wire the contactor. To be honest, I have no clue about electronics or wiring. I just try to follow as good as I can the wiring diagram Klingon Born thankfully sent me along with their parts. The fuse has to be installed between the main power switch and the emergency switch, from which the power goes into the double push button and finally back into the contactor. So let's install the emergency switch now and connect it with the fuse. The next step is to wire the double push button. I had to change the contact elements on the back to the flat type ones, as the original elements collided with the lock of the cabinet's back door. So again a little design fault, but it was easy to fix as Eaton had a suitable alternative for the normal sized contact elements in their product line. With everything wired correctly, I can now install the contact blocks back in place and connect it to the emergency switch and the contactor. With the contactor properly connected, the only thing left to do is to install the working hour meter before power can finally go into the controller's main circuit board. For this, I modified the original cables from the controller, as they already came with the fitting cable sockets. And that's the electrical cabinet with all of its components in place. The controller circuit board has to be installed later when the cabinet is mounted on the machine. As the last step for now, I just had to screw the main switch finally into place. Before I mount the electrical cabinet to the machine, I wanted to do one last thing. From the first day I got the new brushless motor, I thought about replacing the original cables. First, because they smelled extremely nasty, which by the time is gone, but second, because I didn't like the way the cables enter the motor. So I did some research and finally found some Harting industrial connectors, which looked very promising to me. So I reached out to Harting for support, and they thankfully sent me a set of Han 3A connectors. My plan is to screw the angled part directly to the motor housing, so I can connect or disconnect the motor when needed. To do this, I made this additional aluminum mounting plate. And that's how it's about to look like in the end. The Harting connector pins are normally meant to be crimped with a special crimping tool. However, this tool is so expensive that it just doesn't make any sense to buy for only 2 connectors. Instead, I'm going to solder the cables onto the pins. As I don't want the nasty fumes in the basement, I'm doing this outside. So don't mind the changes in lighting and some birds beeping in the background. And yes, I did cut the cables a little bit too short, which made installing everything into the connector housing a real challenge. Soldering the pins was definitely the easy part, but getting every pin into the right place in the tight space of the connector housing seemed to be almost impossible and was really nerve-wracking. And yes, the cables were really a few millimeters too short. I somehow managed to get everything finally into the right place, but ripped one cable apart on the way, which I had to extend and reconnect. And that's the finished motor with its new installed connector. Next is to make the motor connector cables. Instead of the original connector housing, I changed to another one with an integrated cable fitting. This new housing is a little bit shorter, which is a good thing as space is very tight behind the machine. The two cables are protected by a plastic tube, which will be screwed directly onto the electrical cabinet. Now the only thing left to do is cutting the cables to the right length and installing some Molex mini-fit connectors onto the ends. With the new motor cables installed, the electrical cabinet is now ready to be screwed onto the back of the machine's headstock. As the last part missing, I can now install the controller's circuit board. And we're finally done with this project. Okay, not quite. There's one thing still missing. The original controller had this button foil on the control panel, but I really didn't like the look of it and wasn't even sure if it will survive when being removed. So I designed my own ones and ordered a set of from a manufacturer in China. This self-adhesive button foils have a silky smooth surface and a transparent window for the display. The 4 buttons are a little bit domed, so you can actually feel them with your fingers. As I had to order a minimum of 100 pieces, I will sell the rest of it on eBay. So if you have the same motor set or similar projects in mind, feel free to click on the link in the video description and find the product on eBay. And now it's finally time to start the machine with its new controls by setting the main switch to the on position and pressing the green on button on the control panel. Now the working hour meter is counting and we can start the machine with the main on-off lever on the bed slide. So far so good. Everything seems to work quite well, but I made one expensive mistake in the wiring. The emergency switch cuts off the main power input, which doesn't stop the motor immediately, but lets it some time to roll out. This is problematic, as the motor, while running out, sends back some current into the controller's main circuit board, which this, while being not under power, can't handle. As a result, after a few times of pressing the emergency switch for testing, the controller was dead. So I had no other choice than buying a new motor set and changing the 2 circuit boards. To not make the same mistake again, I also changed the wiring of the emergency switch. Instead of cutting off the main power input line, I'm now sending one of the speed sensor cables through the emergency switch. So when the red button is pressed, the connection to the speed sensor is interrupted, which immediately stops the motor. The controller itself, however, will stay under power. So this is not exactly what you expect from a real emergency cutoff. You normally want the whole machine to be shut down and a protection against restart, which is not given here. But it's better than being forced to buy a new motor every time you use the emergency switch. With this all done, the project is finally finished. I'm really happy having proper machine controls now, after almost 2 years of improvisation. Again, many thanks to Ethan, Klinger and Born and Harting for their generous support. Thanks for watching and till next.